terms that we have. So I want us to look at the gradients and equations of a straight line as my starting point. So yeah, so I look at gradients and equations of a straight line. Not a very exciting topic, but I know you and your teacher have looked at it, and you had your own views about it. So when we think of a line, like now the one I've drawn, line is a combination of so many points, spontaneous, towards the same direction. So if you're really spontaneous towards the same direction, we say that is a straight line. And the gradient of a straight line, so the gradient of a straight line is the steepness of a slope, the steepness of a slope. How steep is the slope? Like, I don't know, most of us we go up country during the holidays, and some of us maybe come from each other like me, and we know what a slope is. And there's that slope that you look at and you say the slope is so steep, and sometimes tedious to climb. And we have other slopes that you feel that they are relative, and that is exactly what we mean by gradient. So the bigger the gradient, the steeper the slope. But for you to get about that slope, there must be an imaginary vertical line like this, and an imaginary horizontal line, which maybe is the sea level. I don't know. So we have a vertical line somewhere that is imaginary, and we have a horizontal line somewhere, and our slope is right there. You know, the slope in your village. In my village there are many of them. So the gradient here, so we say that the gradient is equal to the vertical length I divided by horizontal length. And in relation to this, when I look at different slopes, like I've talked about, you going to your grandma's place or your up country, depending on where you live. For those who live in town, there are those slopes that looks like this. There are other slopes that are more relative like this, other slopes are like this, and we have other grounds that are just exactly that. So if I take slope A, B, C, and D, I'll say and also let me just include an E here and say this slope here, my slope A is steep, this one is a bit relative and friendly, this one is actually almost there's no slope, and this one there is no slope. So I'll say this is 0 gradient. And here I have other slopes, and this one is the steepest of all. So this one is very steep. But then from this being very steep, we have another one that we cannot even describe as a slope. So we call it infinite slope. And I want to draw it right there. The one is parallel to the vertical. So it is exactly a vertical line. So this one I'll call it an infinite slope. So from 0 gradient, steep slope, steeper, steepest, and then I have the very, very steep slope there. And as I've said, the gradient should be equal to the vertical divided by the horizontal length. And so this is my infinite, yes, infinite. meaning that it cannot even be described as a slope but a vertical line. So when we come to looking at our Cartesian plane, I know we know about it. I know you and your teacher may have looked at it back in Form 1, because this is Form 2 work. You looked at Cartesian plane, and this is what you had. You had one vertical line and another horizontal line there, and this was your y-axis, and this is definitely your x-axis. And on this side we have the negative values, on this side we have positive values, maybe 1, 2, 3, 4. This side I have -1, -2, -3, -4. On this side I have 1, 2, 3, 4. On this opposite side, -1, -2, -3, and maybe -4. So when it comes to a Cartesian plane, we have different lines on the Cartesian plane, and we say those that are parallel to the y-axis, this line here, right here. So they have so those that are parallel, like now a line that I'm drawing right there, this line here is infinite or undefined gradient. So we cannot say it's steep. That is true. We cannot say it's steep. We cannot say it's a zero gradient, because it's parallel to the y-axis. So I'll say that line right there is undefined gradient. And then I have another line here that is parallel to the x-axis. Let me just draw it right here, and I'll compare it with that, and I'll call it a zero gradient. So that is my zero gradient. So I have undefined gradient parallel to the y-axis, and I have a zero gradient parallel to the x-axis. Then from there we have others, like when you go up country, this is what you find. There is the slope. This is where your grandma lives. This is another friends where your friend live, and so this I'm going down, and this one I'm going up. So the same thing applies here. So when it's a gradient running on that direction, on the positive direction, I call it a positive gradient. And then when I have one running from the positive to the negative, I call it a negative gradient. So that is it for today. I hope you really enjoyed learning about the gradients. So next time you go home, you should know that this here, right here, is undefined gradient, like this one here, right here, parallel to the y-axis is undefined gradient, and then parallel to the x-axis is zero gradient. There is no steep there, just the same we usually say kwa kuna mlima. And when it's running positive, you have to go uphill, so that is a positive gradient. When it is running towards the negative values here, the negative values of y, we call it a negative gradient. So that is it for now. Bye.